Okay, so yesterday, where we have talked about was, was this determinant. Okay, so I kind of like kept saying it's the discriminant, but it's not, right? It's the determinant. Okay, so remember the determinant. There are two cases for the 2 by 2 matrix, and then the 3 by 3 matrix. And by the way, if you were not present in yesterday's meeting, or if you haven't watched the recorded lecture of yesterday's class, then you'll probably have zero idea what I'm talking about. So I mean, like at this point, like you cannot just like watch the previous lecture, but so right now focus on today's lecture, and then make sure to watch the yesterday's lecture, because yesterday we have studied some kind of very bizarre object in math. Okay, so remember how to find the determinants of 2 by 2 and 3 by 3 matrix. So why have we studied the determinant? Because there is a really famous rule, but it's really brilliant. It's really brilliant, invented by some mathematician, okay? And you can guess what his name is. It's called the Cramer's rule, okay? So this Cramer's rule is used to solve the systems of equations, okay, which we have seen a few days ago, and which is also part of today's exam, right? Okay, so the Cramer's rule is invented by a guy whose name is like some kind of Kramer. I don't know what his first name is, but I think it's something Kramer. Okay. But the thing is, he was indeed brilliant. Okay, like that's for sure. Yeah. Now, so remember we have had 3 methods of solving systems of equations. They were graphical method, which is not that significant, and then substitution method, which is useful and it's part of today's exam, right? And then the elimination method, okay, which is also important and is part of today's exam as well. And then this Cramer's rule, okay. So for me personally, I love this Cramer's rule and also the elimination method. But the Cramer's rule for systems of 2 equations goes like this. Okay, so for substitution and or elimination method, what we did was we looked at either the coefficients, or we have isolated x or y, and then we plug or the substitute the other side into the second equation. Now here, now we know the matrices. The Cramer's rule deals with the matrix, okay? So step number 1, form a matrix by aligning all x coefficients in the first column, okay? And then all y coefficients go to the second column. Okay, so I will say this is the matrix, or I'm sorry, the mother matrix, and you'll see why. Okay, or you can, you know, like if the word mother kind of bothers some people, just in case, you can say parent matrix or something, but I don't know, like I guess the word mother is okay, right? Yeah, apparently these days, like I have to be very careful with the word choices, so I don't know. Anyways, the parent matrix, okay? And you'll see why, okay? So this is the first matrix, which is the mother matrix. And now, form another matrix, matrix number 2, by replacing the first column of the matrix 1, the mother matrix, by the numbers on the right. Okay, so now at this point, the expression, the numbers on the right may look confusing, but once we actually do the problems, this will make sense, and it's actually pretty easy. Okay, so the second matrix is formed by replacing the first column of the previous matrix, the mother matrix, by what's on the right. Okay, so you can, I guess what goes into step number 3. So form yet another matrix, so that's matrix number 3, by replacing the second column of not the previous matrix, but you always go back to the mother matrix, okay? So matrix 1 by the same thing, what's on the right. Okay, so basically, whenever you replace certain columns of a matrix, you always go back to the parent matrix, okay? So basically, what does it mean? This mother matrix produces these two like children matrices, okay? And again, at this point, we have formed 3 matrices. And now, step number 4, find each determinant. Okay, so here the keyword is each. Because, why did I say each? Because here we have found 3 matrices, right? Okay, so you have to find 3 determinants, okay, 1 for each matrix. Okay, and then there is a special notation to denote the determinant. Now, yesterday, we have seen the notation of the determinant, which is the absolute value. Okay, not here, okay, not for this Cramer's rule. The notation for each determinant goes like this. Okay, so the capital letter D, okay, which is kind of the letter used to denote the LA Dodgers if you are a baseball fan, but whatever, there's no baseball here. So the capital letter D is the determinant of the mother matrix, determinant of matrix 1, the mother matrix. Okay, and again, be careful, the D is the determinant of the matrix, not the matrix itself. Okay, so D is not the symbol for the matrix, it's the determinant of the mother matrix. Okay, and then the D sub X. Okay, so the same letter D and then subscript X. This is the determinant of the second matrix, matrix number 2. Okay, so again, D sub X is not the second matrix itself, it's the determinant of the second matrix, which is what? Replacing, or it's obtained by replacing the first column of the parent matrix by the numbers on the right, okay? And then the last thing, D sub Y. Okay, so D sub Y is the determinant of the last matrix, matrix number 3. Okay, so once again, D sub Y is not the third matrix, it's the determinant of the third matrix. Okay, so you must know these 3 notations because these will not only appear on your homework, but also on your exam 4 and possibly on your final as well. Okay, so you must remember these notations. Okay, and now the last step, set X to be dx over d, and then the y to be dy over d, and then simplify each. Okay, the common mistake here that people make is flip these 2 fractions. Okay, so d over dx and d over dy. Okay, but no, d is always the denominator. Okay, and if you think about it, the denominator of the fraction is the base of a fraction, which kind of is related to the word mother or parent, okay? So the d always goes to the denominator, okay? So this is the scheme of the Cramer's rule. Now, can I go to the next page? Okay, so yesterday, we also saw the systems of 3 equations, okay, which means there are x, y, and z, which is still part of today's exam, right? Okay, which you have to know, okay, and hopefully people got it, so now, can we apply this Cramer's rule to the systems of 3 equations as well? And the answer is yes. What's the difference? There are a few extra terms, and then it's just a tad more tedious. Okay, so here are a few remarks. So for systems of 3 equations, okay, so remember we always have to find the parent matrix or the mother matrix, right? Now, here, remember we will see another letter z, right? So what does that mean? X coefficients will go to the first column. That stays the same. Y coefficients go to the second column. That stays the same. And then one more. What is one more? The z coefficients will go to the third column, right? Okay. So here the z coefficients go to the third column. Okay, so there is an extra column here. Okay. And now, what do we have to do next? So now we replace the columns, right? Okay. So we got the second matrix by replacing the first column of the mother matrix, okay, which is this one, right? The matrix number 1, the mother matrix, by what? What's on the right, right? Okay, so same thing. And then we replace the second column of this matrix by what's on the right. And now we have to do one more step, which is what? Replace the third column of this matrix by what's on the right once again. Okay, so at this point, how many matrices have you found? 1, okay, and then 2, 3, 4, right? Okay, so for the 3 equation cases, you have, or you should find 4 matrices. Okay, so that is another difference. And now what is the next step? Find the determinant of each matrix. Okay, so now, again, there is an extra notation for one of the determinants. So will we see the letter D? Oh yeah, it's a determinant of the mother matrix, right? Matrix number 1. Now, will we have D sub x? Oh yeah, what does that mean? It's a determinant of what? That matrix, right? Replacing the first column of this by what's on the right. Do we have D sub y? Yeah, and what does that mean? Replace or determinant of the matrix that's obtained by replacing the second column by what's on the right, right? And now there is one more, which is what? D sub z. And what does that mean? Replace the third column of the matrix 1 by what's on the right. And its determinant is D sub z, right? Okay, so you can guess what x, y, and z should be. So x was, remember, what? Dx over d, right? And y was dy over d. So you can guess what z should be. Dz over d, right? Okay, so it's pretty much the same. Okay, but there are lots of work, or like more work than when we had 2 equation cases. And that's reflected on the next problem. Okay, so on number 5, there are 3 parts, and 2 of them, thankfully, deal with the 2 equation problems, or 2 equation systems. Okay, and then on the next page, there is a system of 3 equations, but we are gonna use the Cramer's rule there as well. Okay, so solve it using the Cramer's rule. If d is equal to 0, use something else. Okay, so here other methods mean what? Substitution or elimination. And why do we have this extra condition? Because if d is equal to 0, what do you notice? We get undefined fractions, right? Okay, so people commonly think, oh, okay, so that means the answer is no solution. Well, that may not be true. Okay, so you don't know. So that's why it says you use other methods to solve. But for now, for the following problems, you don't have to worry about this extra phrase because d will never be equal to 0. How nice is that? Okay, so we have 4x plus 3y equals to 2 and x minus 2y equals 5. Okay, so now, even though we have seen substitution and elimination methods, we are not going to use them, and we cannot use them. Why? Because it says use the Cramer's rule. Okay, and of course, you have to know how to use substitution and elimination methods for today's exam, right? So why do I have to mention them right now? Okay, so let's see. This is what? 2 equations, right? So thankfully, we don't have to worry about this, the white box. We have to look at what? This orange box, right? Okay, so first what do we do? Take all the x and y coefficients and put them in first and second column respectively, right? Okay, so now what does that mean? What are the x coefficients? 4 and 1, right? Okay, so x coefficients are 4 and 1. Okay, so now why did I write them in a vertical way instead of, the usual horizontal way? Well, you'll see. Okay, and then the y coefficients are what? 3 and negative 2, right? Okay, so remember, 4 and 1 go to the first column of a matrix. 3 and negative 2 go to the second column of a matrix. So what is the matrix number 1, or the parent or mother matrix? It is 4, 1, 3, negative 2, right? Okay. And so what is the order of this matrix? 2 by 2, right? Because it has 2 rows and 2 columns, right? Okay. So that's it for step number 1. And now, form another matrix. So if we go back to the scheme, okay, so how do you form the second matrix? Replace the first column by the numbers on the right. Okay, so now, what does that mean? Replace, what's the first column? 4, 1, right? Okay, so replace 4, 1 by, now, do we have something on the right side? Oh yeah, 2 and 5, right? Okay, by 2, 5, like this. Okay, so now what does that mean? This means the second matrix, matrix number 2, is what? Instead of 4, 1, we will have 2, 5, right? And now, does 3 and negative 2 stay the same? Yeah, because we haven't touched it or touched the second column, right? So 3 and negative 2 stays the same. Okay, so that is the matrix number 2. Okay, and now step number 3. Now what do we do? So if we go back to the scheme, we replace the second column of the matrix 1 by, again, what's on the right. Okay, so what does that mean? We replace 3 and negative 2 by, same thing, 2, 5, right? Okay, so what is the matrix number 3? Okay, so now be careful. When you replace 3 and negative 2 by 2 and 5, you don't replace it from matrix number 2, right? You always go back to the mother matrix, okay, right here. Okay, it's not this one. Okay, so what do you get? It's 4, 1 for the first column, and then we have 2, 5, right? Okay. So now we have found all three matrices. So now what's the next step? Determinant, right? Okay. So first, let's find the D. Okay. So now remember, what does D represent? D is the determinant of the first matrix, right? Okay. And yesterday we have seen this notation. Remember that? Okay. The matrix with without the square brackets, but if you see this absolute value notation, that means the determinant, right? So remember, how do you find the determinant? First, you go this way, right? And then you multiply them. So what is this? -8, right? Okay, and then where do you go? The other way, right? Okay, and then you multiply, so what do you get? 3, right? Okay, and then what do you do with -8 and 3? You subtract, right? Remember that? Okay, so what do you get? -11. Okay, so -11 is the D. Okay, and now D sub x. Okay, so now what is D sub x? It's the determinant of what? The matrix number 2, right? Which was 2, 5, 3, and -2, right? Okay, so now what is this determinant? So first 2 times -2, and what is that? -4, right? Okay, and then this times that, so that's what? 15, right? Okay, and then in the middle, what do you have? The subtraction, right? So -4 minus 15, so that's what? -19, right? Okay, and now the last one, dy. Okay, so now what does dy mean? It's a determinant of this one, right? 4, 2, 1, 5. Okay, so what is this? That times that, so that's 20. And then that times that, so that's 2, and then subtraction, right? And so what is this? 18, right? Okay, so again, d, dx, and dy are all numbers. Okay, they're not the matrices. Okay, so now, how do you find the value of x, y, or x and y? So x is equal to what? Dx over d, and y is dy over d, right? Okay, so from here, okay, so now let me go up instead. Okay, so x is equal to dx over d. So what does that mean? The x was what? -19 over -11, which is d, right? Okay, and then y is dy over d, and what is dy? 18 over -11, right? Okay, so now simplify each fraction. So there is only one way to simplify the first fraction, which is equal to what? That, right? Yeah, and you cannot reduce 19 over 11, right? And what's the only way to simplify the bottom fraction? Pull out the negative and put it in front, right? And that's it. So what is the answer? Remember, the answer to any systems, especially of two equations, is what? In ordered pair, right? Okay, so what's the answer? 19 over 11, comma, -18 over 11. Okay, so that's the answer. Okay, remember, you could see fractions as your coordinates, right? Okay, so even in today's exam, even if you see some fractions as your coordinates, don't be panicked, okay? That could be the right answer, unless you have made a mistake, of course, which is kind of sad thing. Okay, so that is part A. And now B. Okay, so now B. 5x plus 4y equals 10. 3x minus 7y equals 6. Okay, so now I might shorten some steps compared to what I did in the previous problem A. Okay, so again, what do we do? First, we have to form the mother matrix, right? Matrix number 1. Okay, so what do we do here? So the x coefficients, 5 and 3, go to the first column, right? So we have 5 and 3. And then the y coefficients, 4 and negative 7. So they go into the second column, right? Okay, so you got that? So that's matrix number 1. And now, what is matrix number 2? Matrix number 2. So now you replace what? The first column of matrix 1 by what's on the right, which is what? 10 and 6, right? So what do you get? 10, 6, and then 4, negative 7, right? Okay? And now, matrix number 3. So now, how do you get matrix number 3? You replace the second column by 10 and 6, right? But remember, you're not replacing the second column of this matrix by 10 and 6, right? You always go back to the matrix number 1. So what do you get? 5 and 3 stays the same, and then you have 10, 6 here, right? Okay? Any questions up to this point, finding these 3 matrices? Okay, so now what is the next step? The determinant, right? Okay, so the determinant of number 1, which is D. Okay, so what do you do here? 5 times negative 7, which is what? Negative 35, right? And then minus 4 times 3, which is just 12, right? So negative 35 minus 12. And what is that? Negative 47? Okay, negative 47. And then what is dx? Dx is this one, okay, so 6 times 4, so that's 24. Okay, and then this times that, so that's negative 70, right? Now, does that mean we have minus 70 here? No, right? Be careful, because what do we have? The minus sign and then the negative, right? Okay, so it's 24 plus 70. So what is this? 94, right? Okay, again, lots of sign mistakes and algebra mistakes take place here. And what is dy? So dy is the determinant of this matrix. So 5 times 6, so that's 30. And then minus 10 times 3, so that's another 30, right? So it's equal to 0. Okay, so 47, 94, and 0 are the determinants. Okay, and now solve for x and y. So x is equal to what? Dx over d. So what is that? 94 over negative 47, right? And now, can we reduce 94 over negative 47? And if so, what is this equal to?
-2.
-2, right? Yes. Okay, so this is equal to -2. Okay, and then y is dy over d. So that means 0 over negative 47. And now, what is 0 over negative 47 equal to?
0.
0, right? Yes, it's not undefined, or negative 47, right? Okay, so what is the answer here? The answer is negative 2 comma 0. Okay. Okay, so again, what's bad about these Cramer's rules is if you get a sign mistake on D, guess what will happen? So suppose you got like, I don't know, negative 23 or something like that, okay? Then what's gonna happen? Your X will be wrong, your Y will be wrong, and your answer will be wrong. So everything will fall apart, which is normal in math, right? Okay, so be very careful with algebra mistake. Okay, so that's that. And now,
Before we go on,
yeah,
we were solving that one for the x, what is it, d of x. You multiplied 4 times 6 first. Shouldn't we multiply 10 times 7 first?
indeed.
10
yeah,
times negative 7?
yeah, indeed, yes. So these should be swapped, yes. So negative 70 minus 24, so it's negative 94. Okay, so that's negative 94, so that's plus 2, so that's plus 2. Thank you. Yeah, so fortunately, like this mistake was not too terrible because just like the answer was off by a sign. Okay, so I guess everything else is correct. Okay, so negative 70 minus 24, so it's negative 94, right? Yeah, so yeah, x is equal to positive 2, okay, not negative 2. Okay, thanks. Okay, so that's part B. And now part C. Okay, so now I even I have to be careful, okay, because now we have 3 equations. Okay, so you know what's going to happen, right? So now we will be forming 4 matrices, and each order is what? 3 by 3, right? Okay, not 2 by 2. And we know how bad is this determinant can be, right? It's really tedious. Okay, so let's do it. Let's do it. Okay, just do it. So matrix number 1. Okay, so matrix number 1 is what? So here, the first column is the x coefficients. So what does that mean? 1, 2, 4, right? And then the second column is the y coefficients. So 1, negative 1, and 2. Third column is the z coefficients. So 1, 3, and negative 1. Okay, so there we go. We have a 3 by 3 matrix. Okay, and now matrix number 2. So what do we do here? Replace the first column by what's on the right. So what does that mean? 4, 4, negative 15. And then these 2 columns stay the same. So it's 1, 1, negative 1, 3, 2, negative 1. Okay? And then matrix number 3. So what is this? Replace the second column of the mother matrix, matrix 1, by 4, 4, negative 15. So that means 1, 2, 4, 4, 4, negative 15, and then 1, 3, negative 1. Okay, so now the last matrix, matrix 4, is what? So now you replace the third column of matrix 1 by 4, 4, negative 15. So we have 1, 2, 4, 1, negative 1, 2, 4, 4, negative 15. Okay, so we have 4 matrices. And now what do we have to do? Find each determinant, right? Okay, so now find the determinants. Okay, so since we have covered the basics of or the scheme of finding the determinant of 3 by 3 matrix yesterday. I'm not gonna mention them here once again, but what do we do? Remember, for the 3 by 3 matrix, we first copy the first two columns and put them on the right side. Remember that? Okay, so what does that mean? 1, 1, 2, -1, and 4, 2, right? Okay, and then what do? We look at the diagonals, right? And there are two kinds of diagonals, remember. First, it's, in your view, it's this one, right? Or no, this one. There we go, in your view, okay? And then the next one is what? This way, right? Okay, so first we look at what? That, and that, right? And now, for each diagonal, what do we do? Multiply. And then for this direction, we add. Remember that? Okay, again, be careful with algebra here. So, what do we get? 1 times -1 times 1, or -1, so that's 1, right? Okay, and then plus 1 times 3 times 4, so that's 12. And then another plus 1, 2, 2, so that's 4, right? Okay, and then you go the other way, right? Which is that, and that. Okay, so now remember, for this way, what do? You multiply and then subtract, right? So subtract here, 4, -1, 1. So that's -4, right? Okay, and then 2, 3, 1. So that's another minus, and then 2, 3, 1, so that's 6, right? Okay, and then minus, once again, -1, 2, 1. So that's -2, right? So minus -2. Okay, so now simplify. So what is this? 13 plus 4, so that's 17. And then plus 4 minus 6 plus 2, right? Okay, so what is this? 21 minus 6, so that's 15, plus 2, so that's 17. Okay, and 17 is equal to what? D, right? Okay, and now do the same thing for the other three matrices. Okay, so now copy the first two columns, 4, 1, 4, -1, -15, and 2. Okay, so now we go this, this, and this. Okay, so we get 4 times -1 times -1, so that's +4. And then 1 or plus 1, 3, -15. So that's negative what, 45? And then plus 1, 4, 2. So that's 8, right? Okay, and then minus, and now you go this way. So minus -15, -1, and 1. So that's just +15, right? So it's just 15 here. And then minus once again, 2, 3, 4. So that's what, 24, right? And then minus -1, 4, 1. So that's -4. So it's minus and then -4, right? Okay, and now simplify. So 4 plus -45, so that's 4 minus 45, so that's -41, right? Okay, and then plus 8 minus 15 minus 24 plus 4, right? Okay, so now that's -33. Okay, and then minus 15, so that's what? -48, right? Okay, so we have -48 minus 24 plus 4. And what is this? -72. And then plus 4, so that's -68, right? and that is your dx. Okay, yeah, we are halfway there, so we are making progress. And now the third one, 1, 4, 2, 4, 4, negative 15. Okay, so what is this? So that, and that. So that means negative 4 plus 4, 3, 4. So that's what? 12 times 4, so that's 48. And then plus 1 to negative 15. So what is that? Negative 30, right? Okay, and then minus. Now go this way. So what is this? 4, 4, 1, so that's just 16. And then minus, once again, negative 15, 3, 1. So that's negative 45, right? So minus negative, whoops, 45. Okay, that's negative 45. And then minus negative 1, 2, 4. So that's negative 8, right? Okay, so now let's simplify. So negative 4 plus 48. So that's positive 44. And then minus 30. So that's just 14, right? Okay, so we have 14 minus 16 plus 45 plus 8. Okay, so what is this? Negative 2 plus 45. So that's 43 plus 8. So 51 is dy. Okay, and now the last matrix. Woo, last matrix. So copy the first two columns, 1, 1, 2, negative 1, 4, and 2. So go this way. Okay, so what do we get? That's just positive 15 plus 1, 4, 4. So that's 16. And then plus 4, 2, 2. So that's 16 once again, right? Okay, and then go this way. So minus 4, negative 1, 4. So that's negative 16. So it's negative 16 here. And then minus 2, 4, 1. So that's 8. And then minus negative 15 to 1. So that's negative 30, right? Okay, so now clean things up. So what is this? 15 plus 16, so that's 31. Plus 16, so that's what? 47. And then plus 16 minus 8 plus 30, right? Okay, so 47 plus 16, so that's what? 63. And then you subtract 8, so that's 55. And then you add 30 to it, so 85 is your DZ. Okay. So now we have done the hard work, and now let's put everything all together. So now what do you do? So x is equal to what? Dx over d. And what was dx? Dx was negative 68, and then d was 17. And now, negative 68 over 17, can you reduce this? And what do you get?
Negative 4.
Negative 4, yes. And now, y is equal to 50, or dy over d, so that's 51 over 17. Can this be reduced? 51 over 17. What is 51 over 17? 3, right? And z is equal to dz over d, so that's 85 over 17. And what is 85 over 17? 5, right? Okay, so what's the answer? So for the systems of 3 equations, remember, how do we write our answer? Ordered triple, right? So it's x -4 and then comma y, which is 3, and then comma z, which is 5. So -4, 3, 5 is the answer. Okay, so again, fortunately here I didn't make any mistake. I can see that because I can now remember these 3 numbers from what we have done in the past semesters. But if you make any sign mistakes in the middle of finding these determinants, things will dramatically fall apart. Okay, so please be careful with your algebra. Now, for today's exam, if you want, you can use this Kramer's rule, but I don't recommend it, okay? Because it will kill off a lot of times. Okay, so just use the elimination or substitution methods. Okay, so yeah, it's 12:10, so we already went past overtime. So on Monday, we will go back to chapter 3 and cover one remaining section there, which is 3.5, and then we will go to chapter 4, which we have already done the first section, 4.1, in the exam 2 materials. But we will cover the rest of chapter 4 next week. And remember, next week is what? The last week of classes, right? So we will try to finish everything by Wednesday. If not, there will be some extra lectures on Thursday after your exam 4. Okay? So that's it, and I will see you either 3:30 or at 10 or next Monday. Have a good weekend or have a good 3-hour lunch period.
Bye. Have a good weekend.
You too.